Alright, so today we are going to be creating this effect. Essentially, we have this really large galaxy look right here, and when we click down on the screen, we begin to get this light trail effect. And I know this might not be the best example because I'm recording, I have all these processes going on in the background right now. And so it looks kind of slow, a little janky, but at the same time, once you actually see this without processes running on your own computer, once you use it, you're going to see that it makes for a really cool effect, and this is something that you can put on your website, your portfolio site, wherever you want to put it. So to create this effect, it's not that hard, I promise. It's just a little bit of trickery to get those light trails in motion. So we are going to start with a blank canvas like so. And this is directly from the HTML canvas boilerplate. You can check out the GitHub link in the description. And if you're unfamiliar with it, it's just basically some setup that is going to make developing canvas pieces a lot easier. I have some videos on it that cover how to install it, so make sure you check those out before proceeding with this video. So this is pretty bare bones at the moment. Obviously, nothing, nothing like what we have over here within the finished piece. So to start, we have all this boilerplate code, but we don't always need everything inside of it. The first thing we're going to do is kind of analyze this code and see what exactly we need and what exactly we can get rid of. So we don't need any mouse move events. We are probably going to be keeping the color scheme for now. Just give us a nice assortment of colors we can choose between for our planet. We'll want to keep our resize event listener, so if we go down onto mobile, this will still work. For objects, we'll keep our default object. Implementation, we have this objects array in which we can push a bunch of little mini objects inside of it and then render them out onto our canvas. We have our animation loop. This all looks pretty good for the most part. We just want to get rid of this. Oops. So that's the second time my light has fallen off. If you want an easy fix, always make sure to add Velcro to it. Should never happen again. So looking back at our boilerplate, everything looks pretty good here. We want to keep our objects that we're looping through. We want to keep our clear rect. So we're honestly, once we get rid of our HTML canvas boilerplate text, when we have just this blank slate to work from, we're honestly in a really good place to make what we have right here. So the very first thing we're going to do is start populating our objects array right here with particles. And these particles are just particles is just another word for dots. Basically, these are going to be the planets that are turning and rotating over and over again. So to begin creating particles in which we can populate this objects array, well, we need some sort of default blueprint to work from. So with the canvas boilerplate, we are provided this object blueprint. This is an object class, but it's really generic. We know we don't want just some sort of generic class. We actually want a particle class instead. So this specifies, what does a particle look like? Where should these particles actually go on the screen? What should the radius be? Anything related to a particle is going to be defined within this class, and within this constructor object, this is where we specify what properties this particle has. So with its x value, where it is with its y value, where it is with its radius, color, etc. So this draw function right here already draws a particle. You'll see inside of it, we begin a path, we have an arc, which is basically just another word for a circle, can't stress that enough. We fill it in with a particular color that we specify within our constructor right here, and then we actually call the fill function, which actually puts all that color inside of the particle. Finally, we close it off, and yeah, that basically creates what you see over here, one of these guys at least. Then we have this update function, which just calls this .draw over and over again. We may or may not need this. We'll see as we go on with the tutorial, but we're going to leave this as is for now. Our particle has an x and y, as you can see over here, a radius. These are different sizes, and then they have different colors. They're all different colors. So now we have a way within our code to create multiple particles that are all different from one another to give that unique look that you see within the canvas here. So next step is going to be actually creating these particles and making sure that they actually look different from one another. And that is going to take place within this implementation section. So The boilerplate provides some generic object names. We don't want to be generic when we're writing code. We always want to be specific with what we're talking about. That way, we know when reading this code from top to bottom what it is we're dealing with. So we're not just dealing with objects, we're actually dealing with particles. And we are defining particles outside of this init function and then basically initializing particles as an array within it, because when we are calling init at the bottom, but when we start to resize things, well, we want to make sure that we call init again to reset all of our values. You see, whenever init is called, we are setting particles equal to an empty array. When we resize our canvas with this add event listener right here, we want to make sure that we are resetting everything, and that way we don't just get all of these particles populated every time we resize our canvas. That'll make a little more sense as we begin to test this on mobile. But for now, let's just go ahead and populate this particles array. So we are given right here a default loop in which we're basically creating an iteration that occurs 400 times as specified by this 400 right here. And I would say this probably looks around like 400 particles, but to start, we're going to go a bit lower, and this is just to be safe for performance issues. We don't want to go too high and make all these particles go on the screen and just have everything be slow and kind of just not pleasant to deal with. So instead, we're going to declare we're going to be looping through our loop 200 times, and then for each iteration of our loop, we are going to push a new particle object inside of this particles array. So if we type new particle, which we can do because we define this particle class up here, now we need to actually specify what properties go into each particle being made. And we can always see what properties are available for this object by looking inside of the constructor function. So we have x, y, radius, and color. So what should our default x value be? Well, it's going to be any location on the x-axis from 0 to the canvas's width. So to get a value like that, it's probably a little cleaner to create a constant called x and set it equal to math.random, which produces a value anywhere from 0 to 1. And since it produces a value 0 to 1, we can utilize that to get another random value. So if we multiply math.random by our canvas's width, instead of getting a value from 0 to 1, we're actually going to be getting a value from 0 to our canvas's width. So for each iteration of this for loop, we're going to be producing a new x coordinate, which means each time we create a new particle, each particle gets that new x coordinate, which is going to give it a random location anywhere from left to the right hand side of the canvas. Now we want to do the same exact thing for our y coordinate. We want these particles placed in different locations along canvas, not just on the x-axis and then everything having the same y coordinate. So to do this for our y, we're going to create another constant called y, and it's basically going to be the same exact thing that we see right here. So instead of getting a random value anywhere from 0 to our canvas's width, we're going to be getting a random value anywhere from our canvas's 0 to our canvas's height. So instead of width, we'll say height. And then we know our particle takes y as the second argument, so we're going to be inserting y in here. And then we really just need a radius and color. So we will create random radii as we continue through this tutorial, but for now, let's just go ahead and make them all the same with 5. And then we need to add a color. So same deal, we'll make this random later on. But for now, let's go ahead and choose blue. That's always the first color that comes to mind for me. And then we want to test this out. And the easiest way to test this out to make sure that our particles array is being populated is to just console log out particles. So if we head back to our piece and then right click and hit inspect, head on over to console, you can see when I refresh the page, we have an array of 200 particles. And as we start diving deeper and deeper into this, you'll see that these particles have different x and y coordinates because we are creating a new x and y coordinate each time we go through this loop using math.random, multiplying it by our canvas's width and height. So to go through this, you'll see all of them are going to be different random numbers. Radius and color are the same because we never specified anything random about them. So this is looking great so far, but there's nothing really on the screen at all. And that's because we need to render these particles. Although these particles are inside of this array right here, none of them are being rendered. And to render these particles on the canvas, we have to make sure that we are calling each particle's draw function. If we look inside of this one more time and open up just one of these particles and dive down into its proto property, you'll see inside of this we have our draw function. So we need to call, for each particle, we need to call the particle's draw function in order to get it rendered on the screen, because that is where all this canvas code takes place that actually creates the circle rendering. So to actually get these drawn on the screen, we're going to head on over to our animate loop. And this is what's being called over and over and over again. If I go ahead and console log this out, just put any text inside of there, you'll see it just goes ahead and it starts looping through for as long as time goes until I refresh the page. So for each of our particles, we're basically going to uncomment this piece of code right here. And instead of using that generic constant that we had earlier, we're going to use our more specific constant, or our more specific let, which is our particles array. And what's happening here is we are saying for each particle within our particles array, we are going to call that one particles update function, or we could call it the draw function. These do the same exact thing right now. It doesn't really matter which we do. So if we save this, you'll see all of our particles are rendered on the screen in random locations because we added that randomness with X and Y. So we're off to a really good start here. So next up, let's go ahead and make this background black so we kind of get that illusion of being inside of an actual galaxy. So to make this background black instead of white like we have right now, instead of using clear rect, which basically just clears the canvas every time we are running through our animation loop, we want to use fill rect instead, which is going to fill the background with a color, and then we can draw on top of it. So if we fill our rect right now, everything is just blue because that is what our fill style is currently set to. So instead of the default fill style of blue right now, we want to make sure that we declare a fill style of a string, which is going to be RGBA, and then RGBA takes 4 values. So we want this to be near pitch black. I don't know if I would go completely pitch black just because that provides so much contrast. We'll see how it looks. But to start, we'll go ahead and just say we want this pretty dark background. So we'll add values of 10, 10, and 10 for RGB. And whenever you're using RGB, those values range from 0 to 255. So if you'd like to experiment with this, go ahead and change these values from anywhere from 0 to 255. But now we have this alpha value, and this alpha value really comes into play when creating some sort of light trails effect. We are going to be taking care of this as we continue, but for now, let's make things simple and just add a value of 1. A alpha value right here ranges anywhere from 0 to 1, so it can be 0.1, 0.5. But if we wanted just a pure dark background without any light trails or anything like that, we're just going to specify 1. So once we do this, we have a near black background. It's looking a lot better. We're starting to get that galaxy effect. If I make this full screen, refresh, you'll see we're getting closer and closer. So next up, we're going to randomize the size of these particles. So similar to how we randomized X and Y, we're also going to create a random constant for radius. And this is going to be really easy. Right now, these have a radius of 5, which looks not too bad, but it's kind of big for planets, especially ones that are supposed to be way out there in the distance. And if we start populating this with more and more planets, well, it's just going to get really cluttered really quickly. So I would say like a good base level to start populating planets for a radius is going to be 2. So if we declare our radius as 2, and then right where our radius goes when we are creating a new particle, set that to our radius value instead, you'll see we have a lot smaller planets. That makes it look like they're way out there in the distance. But we want this to be a little more random than what we have right now. We might want planets that are even smaller than this. So to get a random value, all we have to do is multiply 2 by math.random. And since this is any value from 0 to 1, when we multiply 2 by something like 0.5, well, we get 1. Let's say this value of math.random is equal to 1. Well, we get 2 for a radius. So it provides a really nice way to basically get different values anywhere from 0 to whatever number you'd like to get to. So looking on the right, you'll see this is definitely looking a lot more like a galaxy. And we don't even really need to mess with the colors too much. If we just want a blue galaxy like this, well, if we start animating this, we're going to get the same cool effect that we have over here. So how do we get to the point where we're rotating each of these particles individually? Well, are we actually rotating them individually? That is the question. No, we are not actually rotating each of these individually. What we're doing is a nice little illusionary trick where we're rotating the whole canvas. If we rotate the whole canvas, which contains all of these little particles together, then we get the illusion of each particle moving on its own. So how do we actually rotate the whole canvas by itself? Well, this is a little trick I'm about to show you. Inside of our canvas's animate function, this is where we're going to be rotating our canvas over time. We can select what rotation our canvas is currently set at by saying c.rotate. And inside of rotate is going to be radians. And radians is just a fancy word for degrees. It's just a different value that is more mathematic. So let's say you have 360 degrees. If you wanted to rotate this 360 degrees using radians, your value wouldn't be 360, it would be math pi times 2. Basically, degrees will always correlate to radians in some way. You just need a little bit of math knowledge to truly understand it. If you would like a video that kind of goes over the radians more in depth, be sure to check out the video on circular motion I created a while back. It'll go over everything you need to know regarding radians and how to use them within your canvas pieces. So the value we insert right here as an argument for rotate is going to determine how much our canvas is actually rotated left or right. And if I go ahead and insert a value in here, let's go ahead and say 30. Let's see what this looks like. You see, each time our animate loop is called, we are rotating our canvas by 30 radians. Now, radians typically don't have a value of 30. They're typically a lot smaller when dealing with a unit circle. So instead of 30, I'm going to change this to 0.01 and let's see what happens. So when I change this to 0.01, you're going to see we get a lot smoother of an actual rotation motion. If I refresh the page, you'll see it's just way smoother than what we had earlier with 30. But obviously we have this issue where it looks like our whole canvas just goes off the screen. You'll see right here our canvas is square. And if I trace the outline of the canvas, well, that whole square canvas is just being rotated off the screen, and eventually it will come back. But obviously we don't want to rotate it. There it is again. Obviously we don't want to rotate it from the very top left corner, which is what it's doing now. We want to rotate it from the center of the canvas. So to declare where we should rotate our canvas, we need to use c.save, which basically is going to insert you inside this new mode in which you can affect the rotation of something individually from the rest of the canvas piece. So as long as we prefix rotate with c.save, we can add c.translate, which is going to translate the canvas to our new location. Where do we want to translate the canvas to, or at least the center of the canvas in which we want to rotate from? Right in the center of our browser. So if we want to move from the top left over here to the center of our browser, we will translate by an x value of canvas width divided by 2, and a y value of canvas height divided by 2. And this is going to move our anchor point to the very center. And whenever you are using save, whenever you're done with whatever translation code you're doing, you always want to make sure you put in restore, and that's basically going to bring your canvas back to normal where it was. So why isn't this moving like before? Well, when we hit save and translate right here, every time we go through our animation loop, we are taking its canvas from its initial location and rotating it by 0.01 radians. The thing is, we are not continually rotating it because 0.01 is not changing. When we're using save, translate, rotate, and restore, we need to make sure that the value going inside of rotate is continuously incrementing. And when we do that, that is going to give us that rotation effect of it continually moving, but from the center of the canvas piece. So to get some value that increments over time, what we can do is declare a let, and we're going to call this radians because that is what's going to go inside of this rotate function. We are going to say it's equal to 0 to start. We're going to plop it inside of our rotate function. radians goes here. And then at the very end of our animate loop, this is where we're going to say radians should increase by 0.01. So you'll notice, even though I added all this, we did all this work, we're still not rotating anything on the canvas. Now, why is that? So you'll see, as we go through our animate loop, what is happening? Well, we're giving ourselves a fill style, we're filling in our background, and then we are updating each of our particles in their current position. But after the fact, even though we already determined where our particles are going on the canvas, then we are rotating our actual canvas. And when we do that in that order, well, we don't get the effect that we want because our particles are already there. And then we move our canvas, which isn't going to move the particles unless we draw the particles on top of them after the fact. So what we can do is grab where we're updating and rendering our particles, and then after we have rotated our canvas, this is where we're going to draw them. So if we paste them in right here, we are now getting the effect of rotation, although you'll see we move the top left hand side of our canvas to the very center, and we rotate. When we rotate from right here, well, we get this effect of just all of our particles being inside of a box because we are drawing our particles inside of that box, at least when we instantiate them right here within our init for loop. So in order to make sure that we are generating particles on both sides of the spectrum, now that we have translated our entire canvas to the center of the screen, we have to edit our x and y values a bit. So instead of generating particles all the way from 0 to our canvas's width, we need to generate values all the way from negative canvas width divided by 2 to canvas width divided by 2. Might be a little confusing. Let's go ahead and go through it. So if we keep this as is, just adding parentheses to make sure that this is actually computed, and then subtract this by canvas width divided by 2, watch what happens. You'll see that we filled up the left-hand side of that canvas, and we no longer have just 1/4 segment of everything being shown. So what's happening here is, although we are generating values from 0 to our canvas's width, we are also taking into account that we translated our canvas by canvas width divided by 2. So if we subtract that here, well, now we are generating particles that would have been off screen had we not gone ahead and used this translate function. So we can do the exact same thing for our canvas's height. We're going to take what we have right here and subtract half of our canvas's height, which is going to populate the top portion of our canvas that was a little empty otherwise. So looking at this, a lot closer and a lot better than what we had previously. But we still have an issue where it looks like some of the edges of the screen don't have particles populated with them. Well, this is all based on the aspect ratio of your browser. So if we have something that is more rectangular than square, and you'll see this is kind of squarish. If we have something more rectangular than square, well, the width is going to be larger than the height of the canvas. And when you start turning that, well, the width is going to start bringing out these edges that aren't filled with particles. So something really easy that you can do to take this into account is basically just add on some sort of value to your canvas's width and height. We're basically faking that the width and height of our canvas are about, let's say, like 200 to 500 pixels than they actually are. So for each iteration in our loop, if we say our canvas width is equal to our canvas width plus, let's just say, 300, and then do the same thing for our canvas's height. Our canvas height is going to be 300, and then we use this instead of canvas width and height within our actual code that is populating our x coordinate. So we'll take canvas width here, go to our x coordinate, select everything that says canvas width, and replace it with our new value that has canvas width plus 300. We're going to start taking into account those longer sections that are pretty much creating those jagged edges that we don't want. We're going to do the same thing for y. So everywhere it says canvas height within our y setter right here, so right here and right here, we'll paste in canvas height. And now we've pretty much fixed the issue with the jaggedness on the edges no matter what our aspect ratio is going to be. We might have to go ahead and test this on mobile to really get that full experience because the aspect ratio is going to be in portrait rather than landscape. But this should be pretty good to get a similar effect compared to what we have over here. So next up, this is pretty fast at the moment. I'm starting to get dizzy actually doing this. So instead of adding 0.01, which is kind of the rotation speed of our galaxy, I'm going to decrease this to 0.001, and that's going to make things a lot slower, as you can see right here. So next up, to get things looking more like what we have over here, we want to change the color of each individual planet. So we want to make sure that we're randomizing all the particles that you see right here. So right now we're setting everything to just blue, but we don't really want that. We want to set everything to some sort of other color inside of a color array. And with the canvas boilerplate, it comes with an array of colors automatically. So what we can do is just use this colors array set to the constant colors. And here, for each iteration of our loop, we're going to basically set a new color based off of the colors from that array. So in order to select a color at random, we need to access a specific index at random. And to access a specific index, we can use math.random, which, remember, always generates a value 0 to 1, but that's not really what we want, because we can't select an index with something like 0.5 or 0.75. We want a rounded number. So instead, we're going to use math.floor, which is basically going to always give us the rounded number to the bottom of what we have. So if we use math floor with math.random, we're always going to get 0 no matter what. And you can see if we replace blue with our color within our color array, have some sort of bug. We'll just go ahead and open up the console, see what's going on here. And it looks like I just added an extra prefix parentheses. So we'll just get rid of that, hit save, and then make sure that we add this color here. It's not there right now because I did a little bit of debugging off screen. And once I do that, you'll see we have a even nicer blue for our planets, but we're only getting 1, and that's because math.floor is changing math.random into 0. So instead, what we want to do is use math.random to select the full range of values that we have within our colors array. So we look in our colors array, we have 4 values. How do we go ahead and select one of those 4 values? Well, let's go back to where we're selecting our color, and we want to multiply math.random by the length of our color array. And the length of our color array is going to be 4. So if we multiply that by math.random, we are going to get any value from 0 to 4. We use math.floor. If we have some value from 3 to 4, well, it's going to be rounded down to 3. And that means we're going to get any value 0, 1, 2, or 3. Those are the indices within our array right here. So we're selecting the full spectrum of all the colors within our array. If we save this, you'll see now we have a bunch of different colors. So go ahead and add more colors into your colors array and see what kind of results you can get. You can pretty much add any colors right here. As long as you're using this random function to select a random color, well, you're going to get them all populated onto your screen, and it looks a lot better when we go ahead and full screen this like so. Now, we're getting closer and closer to the look right here, but if we look really, really closely into this example, you'll see there's a little bit of blur. There's like a little bit of a glow for these planets, emulating what a planet actually looks like up in the sky. So to create this glow effect, we want to head in to where we are actually drawing our individual particles. And as we draw these particles with fill right beforehand, we want to set this particle's shadow styles. So the very first thing we're going to set is our canvas's shadow color. And this is just going to be equal to the same exact color we're using to fill each individual particle. So we set our shadow color to this dot color, and then we want to specify how big should this actual glow be. And we can do that with canvas's shadow blur property and set this equal to, let's just say 15. That's going to get us a relatively good glow. We'll go ahead and save that. And on refresh, you'll see now we have that glow effect. This is really starting to come together and look more and more like a galaxy. We even have a little bit of flickering. I don't even know if that is intentional. Honestly, you'll see right here, a little bit of flickering. Something with the blur is messing it up. But honestly, it looks pretty dang good right now. So if we want to make this galaxy a little more dense, we're going to head down into our init function. We are running through this for loop, and this right here is how many planets we have. So instead of 200 planets, if we change this to 400, well, now we have a much more dense galaxy compared to before. Really looking really good right here. Now, next step is how do we actually get that light trail effect on click? Well, to do this, what we have to do is change the speed in which we are rotating our canvas to make it go a little quicker, and we also have to change the alpha value within our initial fill style, and that's what's going to create that trail effect as this begins to rotate. Well, I think it's easier to actually go ahead and change the fill style. So we want to change this one value right here. This number 1 is going to be by default 1, but as we hold down our mouse, we're going to decrease it down to a number like 0.05, and that's going to give us that trail effect. So the first thing we want to do, if we ever want to edit a value that's currently a string, we need to make sure that it is a let. So this is going to be called alpha, and we're going to set it equal to 1 by default because that is what it's equal to right now by default. And to insert this into our string, we can get rid of 1, add in a $sign, beginning curly bracket, ending curly bracket. This is a template literal, and it allows us to insert a variable inside of a string. Now, in order for this to actually function, we need to replace our single quotations with backticks. If we're ever using some sort of template literal, we save that and we get the same effect, but now we can edit alpha, and as we begin to edit alpha, this is going to take effect real time. So to edit alpha, we want to make sure that when our mouse is down, we are decreasing this value. So if we look around for any event listener that has mouse down, we don't currently have one. So up here, we're going to copy our resize event listener, replace resize with mouse down, and then we are also going to add a let up here called mouse down. And this is going to be equal to false by default because when we're using our canvas piece, it's probably unlikely that your mouse is going to be down by default. So whenever a user clicks on our canvas piece with mouse down, whenever they actually click down on their mouse, we want to set mouse down equal to true. And this isn't going to do anything just yet, but we're going to utilize this variable to change this alpha value over time. So we know animate is running over and over and over again. Well, as something runs over and over again, it's a great place to edit a variable over time. So inside of here, we can actually do this at the very end. We can say if our mouse is down while we're inside of this animate loop, we are going to subtract alpha's current value. So we'll say alpha is equal to its current value minus 0. Let's just say 0.01, because this is going to be really fast. This loop is going to be happening really, really quickly. So if we do this and then I hit mouse down, you'll see the trails begin to take effect. Now this already looks pretty cool, and it's pretty similar to what we have over here when we hold down our mouse long enough. You'll see as I begin holding this down, we kind of get a similar effect, although it's not really the same one that we get right here. So you could call it at this honestly, but we want to make sure that we get something that looks a lot smoother. So when we're actually subtracting our alpha value, eventually we're going to get down to beneath 0, and that creates these really, really long trails as this canvas begins to turn. So instead of going down beneath 0, we need some sort of limit. So instead of saying our alpha should decrease continuously, we want to say only decrease our alpha if alpha is greater than or equal to 0.05. And if we have two if statements like this, we can just go ahead and combine them using the AND operator like this. So now our alpha value is never going to go below 0.05. So if I click this, and it might even be a little more apparent if I go ahead and change this to 0.5 instead, just so we can see what this looks like. And I'm also going to increase the speed of our turning a little bit just to make sure that we're getting through this a little quicker. So if I go ahead and click down now, you'll see we're getting just very, very small trails at the end of these. That just means we need to allow our alpha value to go down a little more. We'll go ahead and change this to 0.1. Hold down our mouse and see what that looks like. So we hold down our mouse, and you'll see the trails are starting to look a lot better, similar to what we had in the previous canvas piece. And if you're wondering why this is so slow, why it's looking janky, it's just because I have everything recording at the same time on my laptop. If I weren't recording, this would be pretty dang fast right now, I promise. And if I'm wrong, call me out. Call me out in the comments. So now when we mouse up, we want to go back to that original position, because right now, mouse down, everything just turns and turns and turns and never ends the trail. So to go back to our original position, we can add another if. We can actually say else if our mouse is not down, and our alpha is less than 1, then we want to execute some more code. We're actually going to increase our alpha if our mouse is up and our alpha value is less than 1, because 1 is our initial state. We want to go back up to that 1 value. So what we can do is, when our mouse is up, add on the same value that we are subtracting when our mouse is down. And when we do this, well, we're going to go back to that initial state, but we don't have a way to set mouse down back to off, essentially. Because when we're using this event listener up here, mouse down, we're setting equal to true, but there's no way to go back to false. We just set it to false initially. We need a way to go back to that false value. So to go back to our false value, we can add another event listener. We'll just copy mouse down and instead say mouse up. Whenever our mouse goes up, we're going to set mouse down to false. And when we set that equal to false, well, we're going to activate this portion of code right here that adds on to our alpha value and creates that effect that we're seeing right now. So we can toggle between two states. We can toggle between our light trail value with our mouse down, and the light trails are beginning to happen, albeit slow. And then when I mouse up, you'll see that the values go back to their initial state. And that is looking a lot like what we have over here, just a little bit of a different color scheme. So on, off, same deal right here, on, off. So that's it. That's how this effect is created. I hope you learned a lot about translating your canvas, rotating it, playing with alphas, opacities, event listeners a bit to really get such a cool effect. Now, if you would like to take this to the next level, I would recommend go ahead and play with the colors array right here. Go ahead and subtract, add more colors, change the alpha value in which you can go up and down to. You'll see if I change this down to 0.05 or whatever, we're going to get a lot longer trails compared to what we had before. You can even play with the speed a little bit by changing this to a larger number, and you're just going to get a much more apparent effect as you begin to hold down your mouse. So lots of opportunities for playing around here. Add this on your own website. I would love to see it, and send me your code pens in the comments below. So if you enjoyed this tutorial, be sure to head over to chriscourses.com, where I have more Canvas, more web app tutorials to help you become a better developer. Basically, this is a site that I developed on my free time. It's a learning education platform similar to Treehouse, LinkedIn Learning, as it's now called. It used to be called Lynda, but this is basically my way to support the dev community and have them support me in return, so I don't have to do client work the rest of my life. I can actually help more people because I feel like I make a much bigger impact with Chris Courses and creating tutorials for everyone than just doing simple client advertising work for clients. So that's it, and I hope to see you in the next episode. So peace.